Now we have one air loop that serves one thermal zone here. And next step, let me turn off this one first and save. The next step, what if we are building a more complex geometry here? What if we have something like this, it's not a single thermal zone anymore. It's one system has multiple air loop outlets or terminal. Because this is a single loop, it won't make much difference whenever you have one terminal here. But if you are modeling something, a bigger plan, like this one floor, it has 4 different orientations. Typically for the energy models, we will divide these perimeters into 4 zones. So we have one zone facing each orientation, and that provides opportunity to have for the HVAC system to control each zones per orientation. Now, let's see if let me just lock the solver for now. If you open the sample 02 heating, okay, let me open this guy. Oh, I have the sample finished. Let me just copy this one and then save that as a new file and say 02. Tutorial before. Let's start from here. Okay, what I just did is the same zone input from previous sample, but I duplicate into multiple, how many zones I have just, okay. So 2 floors and then you just make a more duplication here. So we have total 200 zones. Okay, and then because we have multiple zones, we have to do use the solvergency to ensure the interior surface are set correctly. And then let me lock this one. Let's go back to, we don't need this. That's fine. Let's keep the unitary system. Let's close. Okay. Now let's see. If we wanna use the same air loop and then for those 200 zones model, can we do that? Let me just copy this guy here, and everything else should be the same. Just copy, Control C, go to the heating before. Let me save as 02 MultiZone system. Okay, and then Control V, paste into the document. Make sure this is turned off and unlock it. Okay, so let me click this one. So the honeybee object is the same object, and this gets error because we haven't really connected to the system yet. So thermal zone, honeybee rooms is honeybee all rooms. Once you connect to it, supply. Okay, so this air loop range is recognizing this input correctly. Basically, we have 200 branches and 1 loop, which is correct. That's what we want. We want to have one central air loop and then supply to each individual thermal zones with terminals. Oh, because right now, because we didn't set the air terminal here specifically, but by default it has a air terminal uncontrolled, which is a diffuser, regular diffuser, added to the thermal zone by default. Just make sure we can add here air terminal. There's one. This guy is a constant volume, no reheat. This is basically the same thing. It won't change anything. And here you get the area because we have 200 zones as the input, 200 rooms as the input here, but we only have one air terminal. If we look at the document here, so we have explained. Let me just draw it. Probably it's easier. Take a screenshot. So these are 4 zones we are going to model for this geometry, for this floor. And because in reality, we have like for this side, for the west facing zone, thermal zone here, we have 4 outlets, 4 atom diffusers here. But inside the energy model, we only model 1 zone for the facing west. We can only have 1 diffuser for this zone. If we want to build a very detailed, if it's like you want to control each terminal individually, then you have divided into this number 4 zone into 4 of them, and then you can assign 4 diffusers to it, and then you have your own logic to control each of them individually. But right now we are going to make 1 thermal zone here, so we only have 1, and because we have 4 zones facing each orientation, then we need 4 terminals for each of them. And for in this case, get back to our example here, we have 200 thermal zones, then we need 200 these air terminals. How can we do that? So basically, if you go to 00 Ironbug tab, there's 1 IB duplicate. If you connect to the reference, the air terminal output as a reference geometry, and then N is a number of duplication, I can do 200. This gives you, let's try to, okay, recompute this component works here. If you look at the output of the objects, you'll get 200 local variables. If we want to make this workflow more dynamic and it responds to the input of the geometry here, because this time we have 200. Next time, probably in next project, we have like 100 zones. How we don't want to go back to here to change the number every time. I can use list length, and let me double click this guy. List length. This gives you 200. And so this value is generated automatically. And then let's use the duplicated air terminals to the air terminals. Now It's fine now. Okay, that's the first one. There is another one to make this workflow more simpler is when you see the all Ironbug components at the bottom left here, there's 3 dots. That means this component has a input for duplication. If you right click this component in the middle and check duplicate number input, so you open up a new input for this component, which is for the duplications. This is the same thing. It's basically combining this duplicate component inside the air terminal. Now you don't have to get this one into the grasshopper. Now we can just connect the 200 to N. It gives you 200 duplications as well, so it's much cleaner. Now let me just use this one to air terminal. Let me control save. Now we have the air terminal set up for this thermal zone. We have 200 thermal zones here, it's fine. But if we look at the unitary system, I guess we can use the same list length component for this unitary system. And then use the panel. So what's the output? It's very slow because this is why we also get 200 unitary system for this case, because we are connecting the zone output to a control zone. And because we have 200 control zones, it automatically generates 200 unitary system based on the number of the input. In this case, it's a control zone. But we really want to make one air loop with one unitary system, right? How can we do that? So we can just pick one zone as a control zone to control the entire building. So let's use list item. For the demo purpose, I'm just going to pick the first zone from the list as a control zone. So the entire system will operate based on the condition of the first zone number 5, room 4. No, zone room number 4 here. Now we have one unitary system and 200 branches, one air loop. So this gives you one air loop. That's all correct to me. All right. Now, okay, we can start to run the simulation because there are 200 thermal zones here. It's gonna take time. I'm going to make this size smaller. Let's say 2 by 2. We will have this seems not correct. Oh, that's the size. Okay, and log Control Z 2020. Oh, that's the distance. Let's just multiply 2. Now we have 18. Is that 18? Okay. What about 1? So that 8 by 2 by 2. This is 2. So we have 8 zones in this case. Now let's double check our air loop again. So we get the A duplication, A terminals, which is correct. So for each input, A loops, A terminals, A thermal zones, which is correct, and one unitary system, one branch, A branches, and one air loop. Okay. Now let's just try to run the simulation with this model. Thermal zone. Oh, it's missing the EPW file. Let me go back to the previous one to find this guy. Copy, paste, and EPW file. And save. Enable solver. Now we get an error. Let's see. The fatal error is unable to determine fan airflow rate. Let's just read through this error message. So there's something wrong with this unitary system. Beginning sizing calculation. Why? It doesn't tell you. I think there's something wrong with the sizing system here. For the unitary system, let's go back. Let's turn off this first. Go back to the script. Auto air saving option, that's fine. That's adding auto air cooling. Let's just turn off that as well. It might be trying to size for the cooling side. Next one. Let's try to run again. Okay. So it has the same error, I believe. Let's go back and check it again. So terminal. Oh, I forgot to connect the cooling coil and heating coil inside. So this unitary system has no heating coil and the fan. That's why. Let me just go back to the previous unitary system. This guy, let's copy everything from here. Control C, MultiZone, Control V. Sure, it's turned off. Heating, the fan. Okay, now that should be fine. Alright, it seems everything runs correctly. And the first thing, let's check the ambient hour. Air temperature, this is ambient hour. So these are all room air temperature. So this is room 422, zone heating ambient hour. So room 423 is ambient hour. Let's see, you can find this, there are a lot of ambient hour for this zone. This is zone 5, this is zone not, zone's fine. It seems there are half of zones are not meeting the heating set point. The cooling, we can ignore the cooling, so all cooling is fine. How can we solve this issue? Right, the simulation runs fine. The heating load is much less than the previous one. So right now it's only 4. I believe previous one is like 20 something for a single zone. But why we are not meeting the ambient hour requirement for half of the zones? Now let's go back to check the script. That's probably because the air loop is operating based on one single zone, room 422. Room 422 is fine. The system is not considering the other zones, right? Let's label the zones based on, we can visualize these zones. Visualize by type. Use visualize, no. You want a color room based on the attributes. Let's color all rooms. So room attribute. Let's use room name. Let me hide. Let me hide the output as well. Room 422 is the dark. This guy. Room 423 is this one. Room 424 is light blue. Oh, it's sky. Okay, now I can see the why. All rooms on the first floor seems fine, has no uncomfortable hours. Basically, it has the same conditions as the first control zone. Because this one, the first one, 422, is our control zone. So, and these guys has the same condition as the control zone, so they don't have the mid hour. And all rooms on the second floor has an issue because the floor is exposing to the direct sun is getting much harder than the first floor. That means supplying. Let me turn on the. See, if you read the room air temperature here, this is room 422. This area, during winter time, is like light blue. It's like 22 here, right? But if you look at the second room from second floor, its indoor temperature is less than 20. It's 18, it's 19, or close to 19 something here. But the maximum temperature is 41 in the summertime, and here is 37. It's way much harder in the summertime, but much cooler during time, probably with no sun. You can see like during during the noon time here, this is like a yellowish. It's around 25, and the first floor is like less than 25. It's like between this yellow and the bluish. It's like 23 something because it's on the first floor, getting less direct sunlight exposure, and the second floor has direct roof exposing to the outdoor and getting way much warmer during the noontime. But before sunrise, It's too cold for the room to maintain the comfortable level. That's the reason. This is before sunrise, the room is too cold, even with the heating system. Does it make sense in this case? And now how can we solve this issue? Let me turn off the system.